Alright, our next lesson is going to be about triangles. And the first thing we're going to talk about with our triangles is something that we call special right triangles. Now, special right triangles, we have two cases. The first kind that we have is a 45, 45, 90 triangle. These are the angles. There's a 45-degree angle, there's another 45-degree angle, then there's a 90-degree angle. And over here we have a 90-degree angle, and then a 30-degree and a 60-degree angle. Now we have a couple special rules. In a 45, 45, 90 triangle, we're going to have a rule that takes us from the leg to the hypotenuse, and then also from the hypotenuse back to the leg. And that rule is to go from leg to hypotenuse, we multiply by the square root of 2. Now it should make some sense to you then. If we're going to go backwards and go from the hypotenuse to the leg, we're going to divide by the square root of 2. Now once we do that, we'll have some radicals that we have to work with, and we have to follow our radical rules. Now here's an example. We know that this is a 90-degree angle because we've got a 90-degree sign, a little box down here. And then we've got two congruent legs, which means that the angles opposite them are going to be congruent. And since the angles opposite, those are both going to be 45, because we've already got a 90-degree angle. Now, to go from the leg, which is root 7, to the hypotenuse, we have to multiply by root 2, so it's going to be root 7 times root 2. We follow our radical rules, and we find out that that is root 14. So the hypotenuse here is root 14. You'll have to pay attention to what the question asks you. If they want you to round to the nearest tenth, you can round that to the nearest tenth. Otherwise, you'll have to simplify that radical. Now, 30, 60, 90 triangles. For 30, 60, 90 triangles, we have a couple more rules. In a 30, 60, 90 triangle, we don't have two sides that are congruent. We've got one side that's the hypotenuse, and then we have a longer leg and a shorter leg. And the rules that we use here to go from the short leg, and we'll mark the short leg here with an S, to go from short leg to long leg, which would be that root 15. To go from short to long, we're going to multiply by root 3. To go from long to short, what do you think we're going to do? Divide by root 3. To go from short leg to hypotenuse, we'll call the hypotenuse H up here. To go from short leg to the hypotenuse, it's probably the easiest one, we multiply by 2. And then to go back, we're going to divide by 2. Now, given what we have up here, we start with the long leg. If the long leg is root 15, how do we go from a long leg to short leg? Well, we have to divide. So this S would be root 15 divided by root 3, and that would end up becoming root 5 for us. Now, we have root 5 as our short leg. How do we go from short leg to hypotenuse? Well, we're going to use our rule. We're going to multiply by 2. So the hypotenuse in this case would be 2 times root 5. Okay. Next, we're going to talk about a little trigonometry. Talk about this term SOHCAHTOA. And it helps us remember what we're doing or how to set things up. As you should all remember, the S stands for sine, the C for cosine, the T for tangent. Now, SOH, S-O-H. The O and the H, as you probably can remember, are opposite over hypotenuse. For the cosine, the A is adjacent, the H is hypotenuse, and for tangent, the O, of course, is opposite, and the A is adjacent. So this word SOHCAHTOA broken down into three parts. All right, we've got the sine part, then we've got the cosine part, and then finally the tangent part. Now, how do we use this? Well, we came up with 5 steps that would allow us to do these problems. And our steps were these 5 steps. Now, let's use those 5 steps to do a problem here. If this is our problem, and we want to find x, we know this is a right triangle, so because it's a right triangle down here, we can do this problem using SOHCAHTOA. First, what angle is involved? And we never use the right angle, we're going to use this angle right here. The angle that's involved is 58. 58 degrees. What sides are involved? Now, we always talk about what sides in relationship to this 58. So, x is opposite. 12 is adjacent. So we figure out we've got opposite and adjacent here. We come over to our handy dandy SOHCAHTOA. We say which has opposite and adjacent? Well, we find out that it's tangent, so we're going to go tangent of 58 equals opposite, which is x, over adjacent, which is 12. So it's x over 12. We're at step 4, set up the proportion. We like to put that over 1. And now solve the proportion. So it's going to be 12 times tangent 58. And if we do that, we should find out that x is going to be, in this case, 19.2. It would be 12 times tangent 58 divided by 1, so that really doesn't do anything for us. We end up saying that x is 19.2. Next thing we want to talk about real quick is angle of elevation, angle of depression. A lot of times people get these confused or do the wrong thing at the wrong time. Remember, elevation, you're looking up, elevating, you're going up. So we've got a triceratops down here, and this triceratops, okay, he's looking up at the pterodactyl, and his angle of elevation is right here. This is elevation, right there. The pterodactyl, flying up here, his angle of depression is going to go down to the triceratops, who's down here. Now, the other thing you always have to remember that it's always measured from the horizon, from horizontal. So, if you have 2 choices up here of A or B, which one's the angle of depression? Okay. It should be B. This is the angle of depression. Okay. We're going straight out here, and then we're looking down. Going straight out, and then we look down. That's the angle of depression. Okay. So that's our triangle review.